Okay, great. We're recording. Thanks for joining, everyone. Tonight, we're going to continue with hypothesis testing. So last week, we covered hypothesis testing for averages. And this evening, we're going to finish that up and we're going to cover proportions. So the best way to do it is to take you to an example. I hope you followed what we were doing last week, because this builds on that. It does help tremendously. But if there's something you need me to just go back and explain, then just let me know. All right, so let's kick things off. I'll share my screen and take you through an example. Now I'm going to ask you some questions on this because I need to get your intuition. So if you cannot see my screen, please do let me know. Okay. All right, so this question might be something you can associate with. So a university claims that 70% of its students are satisfied with online learning. So along comes a researcher, and this researcher believes that the rate is actually decreased. So that means that researcher believes it's lower than 70%. So this researcher takes a sample of 150 students, and out of these 150 students, 96 say they are satisfied. Okay, so let's just pause there for a second. Right now, if you were the statistician or you were just this researcher and you collected this sample, okay, you collected the sample of 150 students and you found out of those 150, 96 of them are satisfied. Now, just based on that, would you be aligned to believe the researcher's claim? Just forget the questions, right? Question 1, question 2. All I'm asking is, the university claims, right, that 70% of students are satisfied with online learning. So they're happy with online learning. But the researcher doesn't believe this. This researcher believes it's less than 70%. So what this researcher does is goes out, randomly samples 150 students, and finds that out of those 150, 96 say that they are satisfied. All right. So just looking at that 150, what is the percent that are satisfied? That's my question. You can put it in the chat if you want. So the option now, is it A, right? The percent that's satisfied based on the sample, right? Is it 70% A, or is it option B, 64%? This is for the sample. So you took the sample of 150, and what percent of those 150 students are satisfied? So what do you say, option A, option B, or you can write the number in the chat. Nobody? Anyone can take a, I'll create a poll, and then you need to answer that. All right. Let me just create that. Percent of sample are satisfied with online learning. And this is important because this is going to be the context for the remaining questions. Option A, option B. All right, so I'll go back to here and give that a try. Please make an attempt on this. I want to see your understanding. All right, so the question I'm asking is, out of those 150 students that are sampled, what percent are satisfied? Chicken ball. Didn't even. Okay, I'm going to select 70%. Let's check what everyone says. Is everyone seeing the poll? Can you just give me a thumbs up if you are? Okay, all right, cool. All right, let's go back to the board. And it's important that you understand this. Does everyone understand that the answer is 64%? That should be the correct answer, because the researcher interviewed 150 students. And the question is, what percent of those 150 are satisfied? Well, the percent is 96 divided by 150 as a percent. You can convert that to a percent, and that'll give you 64%. All right, so the question is, from question 1, based on the sample, you found 64% actually are satisfied, but the university claims 70%. So now if you just drew your conclusion from the 150, you would be inclined to believe that the university is wrong, okay? Because you can see that this aligns with what the researcher believes. The researcher thinks it's less than 70%. And if you drew that sample of 150, it confirms that the percent is lower than 70%. All right, just based on that sample. Okay, that's question 1. So just based on that sample, you'd be inclined to believe the researcher. Okay, I hope that makes sense to everyone. Okay, it's very important. Okay, now this is the second question, and this is going to be a longer question to answer. All right, and I'll explain to you what the difference is from question 2 and question 1. All right, so just remember, all right, you can see that just based on the sample, if you had to just look at the percent from the sample, you'd be inclined to believe the researcher because the percent is lower than 70%. But question 2 tells us to conduct a hypothesis test. Now, a hypothesis test is a more formal statistical test, right? And then once we do it, then I'll explain to you the difference between what we got in question 1 and question 2. All right, so let's start answering question 2. Okay, so I'm going to clear the board. All right, so remember, for hypothesis testing, there are 5 steps. All right, step 1 is to declare H0 and H1. So H0, all right, and H1. Now, if you look at the question, it says that the researcher believes it has decreased. Okay, decreased. So the researcher believes it's less than 70%. So remember what I said last week, okay? In H1, H1 can only take the symbols not equals to, less than, and greater than. And if that is the case, then H0 will take the opposite, which is equal to, greater than equal to, and less than equal to. All right. Now, if the researcher believes it has decreased, so that means it's less than 70%, then that means it has to be in H1. So your less than falls here. Now, we are not dealing with averages like what we did last week. Last week, we were dealing with mu, okay? But that's not what we're dealing with now. Now we are dealing with proportions, right? So in other words, the symbol pi, we're going to be using this symbol because we're dealing with proportions. So we believe pi is less than 70%. That's your H1. And so the opposite of that is just above it, greater than equal to. So pi greater than equal to 70%. And this is a one-sided lower tail test. How do we know it's a lower tail test? Remember what I told you last week? I use these symbols as an arrowhead. Okay, so this points to the left. So it means it's a lower tail test. Okay, now I'm going to look at a little statement here because this is going to help me in step 5. You don't have to do it. Okay, you know, when you're doing it in the exam, but I do it because it makes step 5 a lot easier for me. So H1 is what the researcher believes, because it says in the question, the researcher believes it has decreased. So this is the researcher. This is the researcher's belief. Okay, that's step 1. Now let's do step 2. Step 2 is to find the rejection region. Now, I did tell you last week that step 2 takes the most amount of time to do. Now, because we are dealing with proportions, okay, for proportions, you will always work with the normal distribution. In other words, the Z curve, your Z table in the back of your book. So what is important here is that your level of significance is given to you, and we're going to use that to find the rejection region. So I'm going to draw the curve for the normal distribution, just a rough sketch. It doesn't have to be super accurate. So it's centered at 0. Okay, that's my curve. And remember what we said, it's a lower tail test. So that means the rejection region is in the lower end. So it's here. This is your rejection region. And the size of that area is the entire alpha, or your level of significance, which is 5%. So what is the corresponding Z value that corresponds to an area of 5%? All right. Now that you have to use your table at the back of your book, all right, and you'll find that area. Now we did this last week and the week before, even the week before that. Remember I said you've got to be comfortable at finding probabilities and using the Z table in the back of your book. So here, this value is minus 1.65. So that means anything less than minus 1.65 is going to fall in the rejection region. And everything else on this side of it, we will accept H naught. All right. So that is step 2. Okay, so if you're still not sure how I found the minus 1.65, I'll just quickly recap that. But please, I need you to get comfortable with being able to work with the table, the normal table, in the back of the box. Just give me a second. Okay, so let's get to that table here. Okay, so remember, you have to find the value on the z-axis where the area is 5%. Okay, so I'll just redo the graph I did on the top. All right, it's centered at 0. Now, if you look at the table in the textbook, it'll only give you the area from 0 to a z value. All right, so the thing is, we know we want this area on the left, right? But let's ignore that for a second, because let's just work with everything on the right, because if we find the value on the right, it's just going to be the equivalent negative value because of symmetry. So what we know is that the area on this tail, on the end of the tail, is 5%. And if this area is 5%, then that means the remaining area on the right of 0, and I'll shade that in blue, this area here, Okay. This area has to be 50% minus 5%, because everything on the right of 0 is 50%. So if you remove this black area from 50%, you're left with the blue area, which is 45%. So that means that this value here, that cuts off 5% on the extreme right, you can find it in your table by looking for the area of 45%. So if you look at your table and you look inside the table for 45.45, it's close enough here. Right? If you take this one or you take this one, you would still be right. Okay. If you want to be accurate, you can take halfway between the two, but either one is still fine. Okay. So let's take this one here. Okay. Because it's not exactly 0.45, but it's very close. It's as close as you can get. Right. So if I take this one, let's trace back what the Z value is. So we go along the left here on the margin, it's 1.6. And if you go along the column, it's 5. So it's 1.65. So that means this value here is 1.65. That's how I get the 1.65. But because we are dealing with the area on the left, because of symmetry, the equivalent value, where it's 5% on this side, on the left tail, that means that Z value is minus 1.65. It's just the negative of that. And that's how I get this value. Okay. All right. So that's step 2. Like I said, that's going to be the bulk of the work. Step 3 is going to be easier, but still requires some calculation. Step 3 is compute the test statistic. Now, because you are dealing with proportions, and if you even look at what we wrote for H0 and H1, we are going to look at formulas that relate Z to pi, to the symbol pi. So if you look at your formula sheets, you'll find this formula here, where it's P minus pi all over square root pi into 1 minus pi all over n. That's the formula we're going to use. Okay, now we did this in the previous learning unit as well. This formula, we did go over it in the previous learning unit. So we're actually just using it again. Now, for the values in this equation, we have it already. Pi is just going to be what you have under H0, which is 70%. So you're going to use 70% for pi here. For P is the proportion from your sample. So that's what we did in question 1. That means out of the sample, what is the proportion that are satisfied? So that was what we worked out, which is 96 out of 150. And as a percent, that is 64%. That's your P. And the last symbol we need for this equation is N. And that's your sample size. How many students did you sample? And that is 150. So you have everything to plug into this equation. You feed all of that into this equation, and you'll get a value of minus 1.603. Let's log all around as much as I can. Minus 1.603 6. But if you round it to 3 decimal places, it's fine. So it may not make you panic. Let's round it to 3 decimal places. 64. Either way, it's fine. So that is step 3. All right. Step 4, which is the quickest of all of them. Compare what you have in step 3 to your rejection region here. Okay, so does minus 1.6 land on the left of minus 1.65? Does it land in the rejection region, or does it lie in the acceptance region? Now, minus 1.6 is less negative than minus 1.65. So this value, it lies on the right of it because it's less negative. If it is more negative, if it is minus 2, then yes, it will fall in the rejection region, but it's not. It's minus 1.6. All right, so it's pretty close, but it's still on the right of minus 1.65. So that means we accept H naught. Or in other words, you can also say it is the same as we do not reject H naught. It's the same thing. All right. Now, if step 4 says we do not reject H naught, now let's look at what we wrote for step 1 so we can draw our conclusion. Right. So I'm just going to clear this, make some space here. Okay. Now, if we accept H naught, and that is this here, then that means we are dismissing the researcher's belief because we are accepting H naught. So what are we saying? We are saying that the researcher's belief is incorrect. So I want you to see the difference here from what you did in question 1 and what we're doing here in question 2. Now, question 1, remember the percent that we found was 64%, which are satisfied, and that was less than 70%. So that means, just based on question 1, we would be inclined to agree with the researcher. But if you did the hypothesis test, it actually doesn't say the same thing. The hypothesis test says otherwise. The hypothesis test says, no, H naught is correct, and the researcher's belief is incorrect. And why do they contradict each other? So even though the sample that this researcher took leads us to believe otherwise, because we directly computed the percent of satisfied students, right? And we found that it is less than 70%. But when you do the hypothesis test, it's telling you otherwise. And the reason being, and this is why hypothesis test is done, is because this researcher just did one sample. If 100 other researchers come along and they also draw samples, they can draw 150 different students, or they can even draw less. They can draw 100. Another researcher can draw 1,000 maybe. The number doesn't have to be the same, but the number should be reasonably large and more than 30. And if we have many more researchers doing the same experiment, we would find on average, most of those researchers would end up finding a percent that is greater than 70%, which is why we are finding that H naught is actually true, because it's saying that on average, right, if you do this experiment many times, you are more likely to find percentages greater or at least 70%. In other words, you're more likely to find H naught true. Does that make sense? That is the difference between, when you do a hypothesis test, it can give you a more reliable estimate using probabilities. Whereas if you just took a point estimate, if you just took this one researcher's experiment and you based your belief on that, you could make a mistake, right? Because you're only basing on one experiment. So for step 5, you would conclude, and remember what I said from last week, you always want to start off with what the alpha is, or your level of significance. So from the question, you would say at a 5% level of significance, okay, you can say the data or the experiment to say the data leads us to believe H naught is true. Hence, you could say we reject the researcher's claim. This is why in step 1, I'd like to write what the claim is. So in step 5, it makes it a lot easier to answer that. Okay. Any questions, anyone? Anything you want me to go over? This is pretty much the end of learning in 8. So we've covered hypothesis testing for averages, and we've covered it for proportions. All right. So let me just give you a breakdown, kind of what we did, so you have some context of how this learning unit works. All right. So hypothesis testing. Okay. Now, there's the test for averages, which we did last week. But today, we did it for proportions. Okay. Averages can be broken on into 2 further types of tests. You can either use the z-test or the t-test. Now, just to recap, the z-test, all right, if your sample size is greater than 30, or if they tell you it's a normal distribution, or sigma is known. Sigma is just your population standard deviation. All right. So if all of these conditions are met, use the z-test. But the t-test, if basically the conditions on the left aren't satisfied, use the t-test. So that means your n is smaller than 30. All right. Your sigma is unknown. And so your sample standard deviation is known. So S is known. And they don't tell you it's a normal distribution. Then it's a t-test. That's how you know whether to use a t-test. All right. But you only have to know whether to use the z-test or t-test when you're working with averages. For proportions, it's always going to be the z-test. And that's what we did today. Okay. Floor is yours. Any questions? Anything you want me to go over on this learning unit? Or are you all good? Okay. I'm going to take that silence as everyone's okay. So that is the end of learning unit 8, right? So the next time we see each other, we're going to start the last learning unit, and we're going to finish off with chi-square test. We'll probably break that up into 2 sessions as well. Yeah, but if there's any, and then yeah, once I finish that, then we can start doing revision. But I would encourage you to tell me what you'd like me to revise. It's good to know what students are struggling with, so then we can cover those questions. So I can structure the exercises to cover that. I'm sure you would have got the notification for the NSS and then the masterclass session as well. I'm hoping you watch that. Yeah, and that's helping you with your assignment. Okay. All right, everyone. If there's no other questions, nothing you want to discuss, we can call it. And thanks for joining. I will make the recording available. Yeah, and then I'll see you next week. Go for it. That's a question. If I'm not pronouncing your name, sorry, Lubomir. You raised your hand, or is it a thumbs up? Okay. It's a thumbs up. No worries. All right. Have a good one, everyone. Enjoy the evening.